Start streaming. All right, let's see if we can get this stream to pick up and mess around with some camera problems on the iPhone 6 today. This one, it's pretty obvious what happened. Let's take a look at the board and see what you guys think. Why does this have no camera function? Why could it be? I've looked at this a little bit and I thought it might be interesting for a stream. All right, so this guy says front and rear camera do not work. Let's find out why. Front and rear camera, both cameras do not work. All right, let's see if this is starting to stream anywhere. Refresh over here. I see a hello from Jacob. Live now. Great. And pause. Okay. All right, so let's take a look under the microscope and see if we can figure out why this has no cameras. All right, so camera area, here's the rear camera connector. Let's look in the connector. And looks mostly okay. No pins missing. There's some detritus along here that we should probably get rid of. Other than that, that area looks fine. But the big elephant in the room here is a giant hole in the board at the middle screw, long screw damage area. And we can also see evidence of some long screw damage down in this hole, but the phone does have image, so they got away with that. None in there. So this was pretty egregious. And I've already kind of filleted around here to see what was going on. And it seems pretty intense. I can still see a sponginess of the board right around here, right around there. So there's still some sponginess, which tells us that the damage could likely be in a third layer from here, so even far below here. So first, let's ask, is there anything up with this screw hole that would make us think that we're going to have a problem with cameras? So what's going on at that screw hole? This screw hole generally doesn't cause a lot of problems. You can really bang on it and not have any problems whatsoever. So let's look and see what ZXW has mapped for that screw hole. So come along over here to ZXW land and let's find iPhone 6 screw holes break. All right. Yo, Jessa! Keep you mobile. Do other sensors work? A short in some power rail for the camera or some components that create special voltage. Not sure what that means. All right, let's look here. And in that top layer, ZXW is talking about 1V8, PP1V8. So PP1V8 is a brainstem rail of the phone. So PP1V8, you can't really get away without having PP1V8. PP1V8 goes everywhere. So let's look and see a little bit about PP1V8 in general. If we go back to just the regular ZXW, whoops, I picked the wrong thing there. It's got to load again, so let's go back to screen. Am I on time? I guess so. iPhone 6. Let's look at 1V8 sort of in general. I feel there is a massive demand to fix long screw. Perhaps the special screw is differentiated somehow by color or non-magnetic. There's not really a huge demand for long screw. We see a lot of it because we're fairly specialized for it. It's really an annoying repair. I'm not really sure. Jessa, you got competition. Oh, well, good. This is due to long screw damage? Yeah, for sure. Okay, so let's pick just 1V8 kind of in general. So here's 1V8, PP1V8. And let's just kind of move chat down and take a look around here. So let's look and see PP1V8. Here's a test point for it up there. And I can see a bunch of 1V8 going to some filters that go out to this camera connector. Same here, camera connector. I can see PP1V8 over here at some guys at are going to the front camera. I can see PP1V8 going over here to backlight driver. All of these are resistors that turn PP1V8 into essential I2C data lines for the entire device. Here's PP1V8 going on to be a image power line for image at the connector. PP1V8 is all over the place here inside the CPU. And on the bottom side of the phone, we'll find PP1V8 is an AND power rail. And PP1V8 appears, it's generated by the PMIC. Here it is under Audio IC and Mason. So that's a lot. PP1V8 in general has a lot going on. So if you were to sort of tear this one PP1V8, that is, could have some kind of camera function going on, but also if you were to short it to ground, you could kill a phone through long screw damage to this hole. Meaning that top ground layer, if you were to mash that into that big PP1V8 trace, then you would certainly have a dead phone. So this kind of screw hole damage is either going to cause dead phone, or more likely, no, you won't even notice it. Or there's some potential problem that we could have here, like a loss of camera function in general, because we could have an open line from either something going to the cameras that enables their data or some other voltage, or we could have a loss of this PP1V8 showing up at the cameras. So let's see what we're going to do to kind of troubleshoot that. All right, long screw damage. It's called keep track of your screws in the first place. Just seen some, just mark them with a colored Sharpie, whatever works. Honestly, I don't think it's really a matter of mixing up the screws anymore as much as it is over tightening them. So long screw damage, in my opinion, is from people troubleshooting something else. So you've got a touch problem or a bad screen or something going on, you've jacked up a connector a little bit. And then when you go put a screen on it, you really want it to work, so you really jack down those screws. Don't do that. You just want them to be just moderately tight, not really crammed in there. You can cause trace damage from the normal screw if you just really, really crank it in there, so don't do that. All right, so let's see. You are going to try Chris Long's TriStar with 36. No, why would I do that? That's insane. No, that doesn't seem to solve any kind of problem. I wouldn't have even done that repair. I would have just made the jumpers. Could it not just be caused by an issue on the rear camera? If the rear camera malfunctions, does the camera app not freeze? All right, so that's a good idea. Let's troubleshoot camera problems. If we have no front or rear camera, and this was the first thing that I did, you have to troubleshoot parts and software. So my motto is you don't have a board problem until you know you don't have a parts problem or software. So the first thing I did was I took this screen, put it on a different phone, made sure that front camera worked, and then I reset all settings to reset the camera app, and found that, is this even on camera? Yeah, that it was not a parts problem, not a software problem. So this phone will not produce a rear camera or a front camera image, but that's a good question. Just touch the screws with different color permanent markers. It shouldn't be that big of a deal to remember where your screws go. Is it possible to build an iPhone 5 NAND chip into an iPad Air 2? Don't know, never tried. Yes, that seems to be the true cause. Physically driving the screws into the board. Yes, exactly. Damn cameras. Okay, fine. All right, so let's see what we're gonna do then. Let's go ahead and kind of verify for you guys that this is in fact not working. So let's see what happens on this phone. I'm gonna go ahead and attach a screen with a front camera, and I'm going to make sure that rear camera is plugged in. So here's the deal. Whenever we're going to start troubleshooting a problem like cameras, you have to make sure that you've set the device up so that you can expect for that function to be valid. So for example, if you are troubleshooting cameras, but you don't have a camera attached, then you might get 0 voltages on camera data and power lines. But that doesn't mean anything because maybe you have not created some sort of an enable signal that is dependent on the camera being attached. Similarly, you have to have the cameras attached, the phone booted, and the camera app open so that you are really simulating everything that you would need to actually take a picture. In that case, if you don't see a camera voltage, then you know you got a problem, rather than just you haven't enabled something. All right. So I see the word Tony saying LDO IC chip. So let's see what's up with that. First, let's verify that we actually have a camera problem here. Maybe it fixed itself. Maybe there was never a camera problem. Let's see. All right, it's waking up. All right, password. Oh yeah. Okay, so let's try to do some camera. Camera. Heal yourself, camera. All right, so we got no function here. What was the last thing that was last image here? Yeah, so at one time it had cameras. I can see some, when was that? What's the date on that? I see some pictures in the camera roll. That's another good thing when you're troubleshooting, like for your, it's about a month ago, for your customer, to look at the last date that the camera took a picture so that you know whether or not this came in with camera function. So this undoubtedly came into whatever shop sent it to me with camera function. All right, so we have no front camera and no rear camera. All right, so no camera function at all. So that is true. All right, so what should we do now? Just tape disposable cameras on the front and rear. Problem solved. All right. Okay. All right, so let's go ahead and do some testing then. So let's look at the schematic. Let's look at the schematic and see what we can find out about camera function. So let's see. Let's take you guys over here to the schematic. All right, cameras. What can we learn about camera? Let's start with rear camera as sort of a baseline camera function. All right, so oh, here we are, rear camera connector. So we'll start at the connector. Rear camera connector. What does it take to have camera? All right, I see a bunch of camera data lines, and these probably go to the CPU. So from the camera to the CPU, data. Great. All right, then I've got something called power line rear camera AF, whatever that is, maybe autofocus, I don't know. This is some data lines that probably modulate whether or not the camera is on at all. This, it looks like a power line, a 1V2 to the rear camera, and here's 1V8 to the rear camera, and some other data lines, and then I've got 2V85 rear camera. All right, so this 2.85 rear camera, let's follow that one just for fun, since that tends to be a cause of a lot of problems. Now here's why we're going to pick that one. Let's follow that guy for a little bit. We could, if we wanted to really research, we can follow around every single one of these lines and try to get an understanding of what is going on entirely. But here, let's follow this power line 2V85 rear cam. And it goes through a filter, shows up over here. And on the other side, it's renamed to just 2V85 cam. So instead of R cam, same line is got a different name. All right, so it appears to be an output of this chip, which is called U2301. So U2301 has this sort of special name that we could go learn a little bit more about it. But let's see. U2301, what do you do? All right, I see RCAM, FCAM, AVDD, rail. All right, so I see that VCC main appears to be the input, the voltage in, and that the voltage out appears to be this 2V85 camera voltage. And now let's see, where else does that camera voltage go? We got here by following it back from the rear camera connector, but let's just look a little bit more. Looking around, here's that same voltage, and it goes through this filter, and it becomes 2V85 F cam. All right, so 2V85 F cam, then, if we follow this guy, it's our same power rail, same rail. F cam goes to the front camera connector. So all of this stuff is front camera connector. All right, so then let's kind of go back and let's find our way back to U2301. All right, so why are we here? So this is a special chip because we found our way by following all the different possible power rails or data rails from the rear camera. We picked one and then we followed it back to learn more, and we found that that is generated by this little chip called the camera LDO chip. The camera LDO chip takes VCC main and it puts out this 2V85 camera rail that goes on to power both the rear camera and the front camera. So because in our case we're missing both rear camera and front camera in the iPhone 6, that particular power rail really kind of goes to the top of our list. If we were to research the other guys, we might find that they go separately to either front camera or rear camera. But this LDO chip, let's look a little bit more about that. So let's go back and see what we can learn about it. All right, so how does this chip work? So we have VCC main coming in, and what goes out is a 2V85 camera rail that splits to power both rear camera and front camera. All right, so how does this thing know or when to turn on? So let's see what you guys are talking about. What? Why is that doing that? All chats. Yeah, show me all chats. But how did I mess something up over there? What does that do? I don't want to do any kind of reconnect. Doesn't that just, I don't really want to clear the history of chat either, or else I can't see it anymore. Nope. All right, let's just look over here. Let's see what we can see you guys are saying over here. Oscilloscope. I always tried the jumper first. Not a good idea. All right. Shut up, you both. Yeah, you guys cannot chat. You guys cannot use my YouTube live stream chat to make private connections and business deals. That's not cool. All right, hey bros, shut the fuck off. All right. There's two resistors next to the backlight circuit for camera. There's two resistors next to the backlight circuit for camera. That doesn't make any sense. Backlight circuit for camera. That doesn't make sense. Okay. All right. So I don't understand backlight circuit for camera. That's okay. That doesn't mean anything. All right. So let's just see what happens if I try to restart this little chat app. Because seeing the chat up here on this main screen helps out a lot. So let's see if I can restart that chat, run, and maybe that'll work. All right, so now what do you guys think is the signal that makes the camera LDO chip decide to turn on or not? Okay, lost connections. They're looking for Craigslist. All right, that's pretty funny. Okay, so let's go over and let's take a look at that chip. Let's see if we can learn a little bit more about what does it actually do. Okay, so let's go over and try something like this. All right, so I want to know more about this chip. So let's look it up. So let's just take its number here and copy it, and then let's just go to the internet and say, hey internet, do you know anybody that's got this name? Now whenever you see things like find chips, that's not really as useful. Here we go, mouser.com. That sounds like a good place to start. All right, so Mousers has, hey, I know a guy that's got a name like that, and He's a chip made by Texas Instruments that is a LDO voltage regulator. All right, learn more about Texas Instruments thing. Yes, I would love to. In fact, I'd love to see the data sheet. Fantastic. All right. Okay, Amy says there's there's 2 resistors for the camera next to the black light circuit. All right, we'll come back to that. All right, so here we are. We're going to learn about this chip. So what can we learn here? All right, so input voltage range, output voltage range, output current, blah, 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 blah. So what we're going to do is try to just kind of get an impression from reading a whole bunch of information without killing ourselves to understand every single thing there is to know about it. All right, so here we go. This chip is a low noise LDO that can supply up to 250 milliamp output current, designed to meet the requirements of RF and analog circuits. Blah, 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 blah. Class leading noise performance without a noise bypass capacitor and the ability for remote output capacitor placement. This device is designed to work with a 1 microfarad input and a 1 microfarad output ceramic capacitor. No separate noise bypass capacitor is required. Fixed output voltages in some range. Contact Texas Instrument for more details. All right, so what is the main thing that you got from reading that little blurb? It's a lot of words, and this is the skill here to kind of like extract the nugget. Here's what I take from that. This chip takes an input voltage, it turns it into a different output voltage, and it does that in a way that makes it different from other chips because it's really good at getting rid of noise. I see the word noise mentioned a lot. So it appears that there are other ways to do this that are more noisy than this chip. So if you're interested in not having a noisy circuit, you want this guy. And it's one of a class of guys that take an input and step it down to an output. This guy's unique in that he does it really quietly. He does it with a very clean voltage that's coming out of him. All right, so what does that mean? Lots of people out there say, fuck that chip. Why don't I just take the input, which is VCC main, and that VCC main is going to be a really variable voltage. VCC main is the same as battery. So if your battery is all charged up, VCC main is expected to be 4.2. And if your battery is depleted, VCC main is expected to be 3.8 or even less. So that's a real range. Some people just say, hey, why don't we go and say, fuck this chip entirely, because all it does is it takes VCC main, which can be anywhere from 3.8 to 4.2, and just make a jumper here and turn it into instead of 2.85, let's just make VCC main be the power rail. So instead of being 2.85, we're going to say, fuck you, camera. We're going to make it close enough. You're going to just tolerate the fact that we're going to shove down your throat a voltage that is VCC main. Just suck it up. I know you want 2.85, and apparently you want 2.85 in a very, very clean voltage because you have picked a chip that is known for getting rid of noise. You want a pristine, clean, even perfect 2.85, not 2.86, not 2.84. You want that. Your camera is a sensitive application and you want that 2.85, but you know what? Fuck you. I'm giving you VCC main, I'm shoving it down your throat, and you're gonna fucking like it. You're gonna like it. So people do that all the time. They'll just take VCC main whenever this chip, they knock it off the board whenever it gets heated up doing a touch job, and rather than reballing it, they just say, fuck that chip. So there's people out there all the time that say, fuck this chip. And they will just put a jumper connecting V in and V out so that it is just sending to the camera whatever's on VCC main, screw you camera chip. And the truth is that for some time that generally will work, but you have to think about it. You know, like what's the consequence of that? So the consequence of that is that the camera itself really is pretty sensitive, and it does not like you to give it 3.8 and just say deal with it when it's expecting 2.85. So you will have reduced, like seriously reduced. It won't work. It will not have. It won't work for as long as you want to keep using that camera. So I'm a big fan of practical repair. You know, if you do something that kind of is a workaround or a hack and it's outside design, that's fine. As long as practically the phone is going to last for about as long as you want to use the phone. So if this is an iPhone 6, you know, this phone needs to last, you know, in 2 years from now, you'd be hard pressed to find people still using an iPhone 6. So it needs to last 2 years. It doesn't need to last 100 years. It doesn't need to be able to withstand flying to Mars. You know, it's not the space shuttle, it's a phone, but you do need to do repairs that are going to last for about as long as somebody would want to use the phone. All right, so let's see what's going on in chat, and then we'll see what kind of things that you think we should do. All right. All right. Voltage enable makes the chip to turn on. Yes. I hope this camera challenge cheers me up. I'm still so heartbroken. I'm sorry to hear that. Cut the red wire. What's going on? Chris Long, we're just got a long screw damage in the middle hole on a 6, and we're going to see what we can do to mess around with the LDO chip and get it to work. All right. LDO enable line gone. Yes, it is. All right, iPad rehab, resistors for black laser. Chris, hi, hello, Chuck, whatever. I just noticed Jessa has beautiful eyes. What? Let's see. Data sheets, backlights. LDO is just a voltage cleaning and regulating chip. Clean, smooth, beautiful, crisp, perfect. Lower voltage, yes. All right. Let's see. If I remember correctly, it has an internal transistor that goes to an internal resistor and caps to lower and clean the voltage. Let's see. This is all starting to sound dirty. Yes, says Jorge, I had a dead phone after jumping across the camera LDO. Alrighty. Also creates a battery drain if you have the camera power always enabled with a jumper. Yes. Let's see. Okay. All right, we're gonna be done with that. All right, so let's go back and see what we can do here. All right, so now we know a little bit about what does this chip do and what's the deal. So I want to know whether or not this is really where I'm looking for problems here or not on my particular camera problem. So if I have my camera app open, my camera's connected and everything's set up, then I will probably get some kind of a voltage on this enable line. Now I can look back at the data sheet and try to guess what that might be. So you can read along in here and see what you can do. So let's look at this data sheet again and see. All right, enable input. All right, this is good. Here we go. Enable input. A low voltage on this pin turns the regulator off and discharges the output to ground through an internal resistor. High voltage on this pin enables the output. This pin has an internal pull-down resistor to hold the regulator off by default. Okay, so this tells us now we know a little bit more. So now we know that the default position for the enable line should be 0 off, and that when the CPU says, hey bro, turn on the cameras, then that is going to go up to some higher voltage, which will enable the chip, and then that would generate those output voltages. All right, so let's see if we can do some experimenting then. Let's go ahead and see, let's do some measurements then. So let's turn this sucker back on. So this is our phone, and let's actually measure what's going on at the input, the enable and the output of our LDO chip and see if that's actually has anything to do with this, or are we chasing a red herring? So let's take you guys over quickly to ZXW and see if we can get an idea on where these things are where we can measure them. All right, so here's our LDO chip. All right, so this one is the enable line, and I can scratch the board right there and get a little place to measure. So that is the enable line, and where does it go? CPU, that's it. So it's just a signal from the CPU that would look something like, hey, she just opened the camera app, dude, turn on the voltage like right now. All right, and then we've got, this is our VCC main, so there's a local cap here that has VCC main. This actually cap is one of my favorites because it's the only cap on VCC main on the top side of the board that's not under a shield. So I use this guy all the time to ask, is there a VCC main short? All right, and then what else do we have? This is gonna be our ground, and then this over here is our output. So here's the 2V85 that goes to this adjacent cap. So we should be able to measure 2.85 right here. Okay, so let's do it then. So let's get out the good old trust-based multimeter that is not on the screen. It is kind of too bad. If I was not too lazy to do stuff that it would be very nice for YouTube, then I should at least make it. In fact, maybe I can do a little something for you guys to make it so that you can possibly see anything. Ooh, let's see how long that lasts. That's probably not gonna last. What else could I do? Where could I put this that you could actually see it? Maybe right here? I don't think even I could see it back there, possibly. Can you see that? You'd really have to zoom. And that's gonna fall down. That's not gonna last very long. It's really too bad. I wonder if I could make it work here. Ah! Let's try that. This is gonna work. We're gonna make this great, except I won't be able to see it. But let's see what happens if, oh shit, what did I do? What did I do now? Oh, that's still working. All right, what did I do? All right, let's turn this a little bit like that. And let's use the ye old rubber band. Here we go. Practical multimeter. Ha! Kind of works a little bit. There we go. Yay! Practical multimeter. Okay. Tape it to the side of your head. I think my head is like way too pointy for that. All right, let's see. Is that gonna work? There you go. All right, so now I don't like this logo like right on my head. Let's move that over there. And let's move this back over here. Great. Okay, so now let's go ahead and see what happens. Let's measure some voltages. So first we gotta enable that camera or else it's nothing. So we've got camera open. All right, so now we should be able to measure. All right, so we're gonna just open her up and we're gonna just measure for voltages around that LDO chip. Okay, so I can still see my camera app enabled, so I'm just gonna lay that screen down and I'm gonna have to kick off home button in order to be able to get a reading, confirming that I've got camera app still open, that I didn't like accidentally trigger a home button click. Let's measure. All right, so I'm in volt mode. There we go. I like the on-screen, the iPad Rehab on-screen multimeter. Okay. Now, if I was really smart, I would minimize this so that you could see both in one scene, but What does this still do? Oh yeah, look at that. Ah, all right, look at that scene. Totally profesh. All right, so we should be able to get a VCC main voltage from right here, I think. Is it that side or this side? I think it's that side. All right, can you see the, let's make that big. Because I really have no way to see this now except for on the screen. Let's see. Here we go. Here we go, peeps. All right. So let's move that again, and we're gonna put one probe on ground. Get out of here, you. And I forget what side is ground. All right, there we go, 3.9, that is our battery voltage. So let's check over here on this guy. What is our output on the camera LDO output? 0. All right, now let's check what is our enable. Enable is 0. Let's check. Do I get any kind of flicker? Nope. Enable is 0. So that is a problem, right? Because we know that the enable when low is going to turn the LDO off. Now let's go ahead and try a known good and see what those values are supposed to be. So that does seem like that is a problem. Okay, so this is a phone that's here for backlight, and I just kind of briefly fixed up backlight, so we will borrow it for a couple of quick readings on camera, just to have a known good to compare to. All right, so now, what do you think is the most likely cause, given the fact that this thing has raging long screw damage? What's the most likely cause for why this phone has no enable right now? It has no enable. So there's a couple of different choices. Why would it have no enable for that camera LDO? So we're going to let this other phone boot up and see what the other voltages are. All right, let's see. All right, what are you guys talking about now? Put your e-dicks away. Ha 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 ha. That's pretty funny. All right. What about ground from IC? Not sure. Ground is it's hard to have a problem with ground. Ground pretty much always works. ZXW tool, go buy another one. All right. Tape to the side of your head. Yes. All right. Get one of the beer can holder hats. You know, I had one of those. I thought that was really actually pretty funny. I had one at, I got one at a yard sale. Those things are not as cool as you think they are, because you have to have all these like clamps. They just leak everywhere. I wore it on Halloween. I thought that was pretty funny, but it didn't really work. All right, Bluetooth multimeter, nope. Show this to Lewis. Yes, that's right. Scope brackets, okay. Lewis had an HDMI multimeter. Lewis is on vacation. Yeah, Lewis plugged the battery into his backwards, so I don't really think he gets to complain as much. See, she solved his problem. Text him. What? Ways to undo this. What? What do you mean cam one-eyed? What does that mean? Are you supposed to get voltage from the enable line? Let's find out. Okay, so now we have a different phone. So this is a known good. So let's check out the known good here. And passcode on this dude. All right, so we've got this phone working. Yes, yes, yes. You don't like the fact that you don't have a SIM card. I got it. All right, so this is camera working and rear cam working. So with that, let's go ahead and take voltages on this guy. All right, so I've got the camera is all set up, and now we're going to do exactly the same thing. So let's take a couple of voltages around the LDO. Alrighty, here we go. All right, so I'm going to put a probe here on ground. I'm going to move away the home button flex, and I forget again, I think that's the ground side, but let's find out. Yep, that's the ground side of our VCC main. Yikes. All right, VCC main on this one, 3.5. And now our LDO output, 2.85. Beautiful, crystal clean, 2.85 volts. Yep, 2.85 volts. Now let's dig out and probe in our enable line. So what is our enable line? Enable line looks like 1.76. 1.76. And is this our test point for, I forget what test point that is. Is that the 1.8 test point? Yep. So our general 1.8 line in our phone, and this guy is 1.769. All right. And then there's a local guy here that I think should have 1.76 there, and it does. Okay. So this is what we're going to come back to if we need to try a jumper solution. So right here, 1.76. Okay. All right, so what did we learn from this? So now we know that we have, actually let's do one more measurement where we flip it over from rear cam. So the rear camera is still working, and we're going to flip it over to front cam and just make sure that we don't have any differences with front cam. We wouldn't expect it to, because the output line seems to just split into front cam and rear cam. So let's see, here we go. Let's see, we are gonna do our 2.85. And let's see. Let's go back to here. Get a reading, come on. 2.65, that's interesting. It seems like it's a 2.65. And I think I'm holding that on there pretty well for front cam. Okay, and then let's check our enable line. And then the enable line is still 1.76. All right, so now we kind of have just crossed the box on that. Okay, so now we know that for sure the high level from the data sheet, remember it said when the enable line is high, that is in our application 1.8. So it's the same as the regular 1.8 voltage line everywhere in the phone. So the enable line when high is supposed to be 1.8, and that is going to create an output of 2.85, and that is then split between rear cam or front cam. Both of them seem to use that same line. But it was interesting that when we had rear cam enabled, it was clearly 2.85, and front cam it went to 2.65. So that seemed at least just kind of interesting. All right, so now what are we going to do? So now we know that the primary problem in the device that we're trying to fix is that we're missing that enable line. So why are we missing that? What would cause that line to be missing? And that's kind of a question. So let's see what you guys think. Why are we missing this this enable line? All right, let's see. Is Lewis in California? Yes. do you follow Paul Daniels' channels at all? If I had time, I would. I think Paul Daniels is great. The LEO is split between the two cameras. Yes, it is. In the iPhone 6s, it is separate power rails. Yes, it is. So that is a good point. That don't be confused. Don't apply a problem in the iPhone 6 to the 6s when there's a different architecture. So in the iPhone 6s, you have power coming straight from the CPU for front camera, and rear camera is getting power off of the one LDO chip, which is in a different spot. So the LDO does not power both cameras. If you have a front camera defect, then it's a lack of power, that is a CPU problem in the iPhone 6s. All right, so I'm trying to pay attention. My puppy wants me to throw a ball. All right. Would you make a simple jumper from any local IC with one V8? All right, so we have an idea. Let's see what would happen if we just made a simple jumper and just said, let's make the camera enable always be 1.8. And that's one idea that we could have. That sounds, and there might be a consequence to that. So if we actually said, all right, then rather than saying fuck the chip and that the output is always going to be VCC main, you might kind of say, well, it's a little bit more refined to just say fuck the enable, and that the chip is just always going to be on. It's always going to be enabled, and it's always going to be putting out that voltage. So what would be the negative consequence of that? What would be the downside of doing that? So if we think about other power rails that are in the phone, ones that are like boost rails, for example, backlight or chestnut output, those that have their own sort of separate driver, those tend to be off whenever they are not required. So if you make the display sleep, then you do not generate that 5.7 voltage. If you were to think about the power management chip PMIC rails, like 1V2 SDRAM and 3V3 ACC and 3V0 NAND and all of these different power rails that it makes, those generally are on all the time if they're not for display. So if we think about what it would be the consequence then of having an unneeded 2.85 volt output present all the time, where would it be going? It would be going just sort of to the camera and sort of into the camera, and then it would be kind of sitting there all the time. It would be about the same consequence of leaving a camera that you bought at the store on instead of turning it off and just kind of like letting it sit there. So there may be a consequence on battery life, on current consumption, that the device, may have some sort of a small leak to ground while it's sitting there. But remember the difference between voltage and a current. A voltage is just a push filling up a blood vessel with blood, but it doesn't actually do anything. You're not having current consumption unless you have a circuit, a path for the electrons to flow through. So I'm not sure that there's actually going to be current consumption if you apply the voltage, if you're not actually taking pictures and having the app enabled so that you could use the camera. I don't know. So biggest possible downside then of just jumping the enable would be a potential drain on battery life and a potential shortened lifespan of the camera itself, because it may not be expecting or designed to have 2.85 volts beating on its front door all the time. Whether or not that is going to be a practical difference would be something we would have to determine experimentally. All right, but let's think a little bit more before we go do that. You check camera. Please check memory storage, writing speed too, when user adds more than blah, 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 blah. All right, so this is a point from Paul that says, before you go nuts on camera problems, make sure that, this is back to parts and software, make sure that your problem isn't just that the phone doesn't have enough space. And this is true. If you were to fill up your camera storage space to so much that I can't even take one more picture, then you'll find that at least in some devices, the cameras will default to off because there's not enough space to take a picture. But that's not the case here. All right. The line comes from the CPU. You can grind the front edge of the RAM off and solder a wire. All right, that would be super fun. So I love this idea, and we do not have permission to try that on this phone. However, this sounds super, super fun. So Chris's suggestion is, hey, how about this? Since, and we haven't confirmed this, this is a little bit premature for where we are right now, but he's saying, how about this? If you look at, hey, you're missing this enable line. Why? Where does it come from? It comes from the CPU. So the CPU, this is the CPU, and on top of this row of balls is the SD-RAM. And it turns out that the SD-RAM chip itself that sits on top, so let's take a look at SD-RAM sitting on top. So where's one that has the CPU off? So right here, that the SD-RAM chip here, the one that is this top chip on top of the CPU, the corners of it tend to pretty much just be ground. So you can actually, believe it or not, for real, legitimately, you could make a little incision here and not bother the SD-RAM chip itself. And then you get to the CPU, the top of the CPU, and in theory, you could, this is just sort of theoretical, in theory, you could then get to that top of the die of the CPU, whatever spot was the same trace as the underlying connection to the board, and put a jumper there and then go out to the enable pin. What problem would that solve? It would specifically solve the problem that the long screw damage has broken continuity between the CPU and the enable via. That you've got a wire somewhere that's broken, and that's why the CPU is putting out 1.8 volts, but it's not making it to the enable via and into the chip. So if that was the reason why we're missing our 1.8 enable voltage, then it does make sense that, well, could we just go to the CPU and instead of trying to tag into that ball or lift it up, put a jumper and put the CPU back down, could we just scrape the very top of the die, the chip, and expose and find that spot, solder a wire, and bring it over to the camera LDO? My opinion would be that would be super fun if this was a throwaway phone that didn't, that was just a proof of concept or something that you wanted to do just for fun. I don't think that the consequence of just enabling the 1V8 there all the time and that potential drain on battery life, I don't think that that's a practical problem that would be worth the risk of drilling into the CPU just to solve a potential battery life problem on a phone. I don't think so. It would be something maybe you could do this and say, hey, if you don't like the battery life and you'd rather just throw the phone away, then bring it on back and we'll see if we can do something that's more fun. So that's what my thoughts would be on the CPU solution. But again, it's a little bit premature because we don't know why that enable line is missing. Is it missing because of a lack of continuity or not? All right, usually putting pressure on this area of the CPU will make the cameras work. Chris Long, are you talking about that in the context of long screw damage? Is this going to affect the battery life? Well, we don't know. We'll have to decide. We'll have to see how much it affects battery life, if at all. Practical repair, use a screen on 1V8 reset line for, say, LCD to enable the camera. Use a screen? What does screen mean? Use a screen on 1V8 reset line? What does that mean? I don't get the screen part. At least have some power saving. All right, so it sounds like what Chris is is talking about is saying, well, let's say that you wanted to make the 1v8 jumper to the enable line. So what source of that should we take? We could take any 1v8, like 1v8 always, and always have that line enabled. Or could we find something that's like a little bit more of an intelligent signal? For example, you don't ever really want to have the cameras turned on if your screen is not on, so maybe we should just borrow 1v8 from a line that we would only expect to be present if the screen was on. It sounds like he's saying a 1v8 reset line for, say, LCD to the camera. I'm not a huge fan of that just because there's too many variables for timing there. Because 1v8 reset line for LCD goes off and on all the time. All right, battery drain, battery drain, battery drain. Grind that SD RAM off. Well, I don't know that that's why we don't have 1v8 at the enable line. I have an iPhone 6, camera not working front and back. Great, then you should watch this video. Super glue a magnet on the back of the meter. Oh, okay, I thought that was going to be way cooler. Check the LDO output. Yes, time to learn. All right, ask Jessa. Go back and review this video, and we've just totally covered that. All right. When writing and recording to energy-sucking SD cards, camera voltage can get too low. Spikes and ghost pics can result. Frame loss on videos. All right. Break in line or the enable pin short to ground. All right, that's a good thing. Let's check to make sure that the LDO is not shorted to ground. Don't jump. All right, what else are we talking about? I've done that one, no luck, but it was exciting. Don't do that. SD RAM is 2-pack. I'm not really sure what that means. What? Please use a multimeter that shows low and high values, so a non-stable pulsed power signal is detected. I don't think any of that is important. Long screw damage. Didn't know it had long screw damage. Yes, it does have long screw damage. It has massive long screw damage. This phone has long screw damage. Here, see if you can figure out what lines might be broken. Yeah, this phone has long screw damage. Dun, 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 dun. All right, so that phone's totally got long screw damage. Not near ZXW, but I believe the bottom right hole has camera lines. Well, that's the only one that they didn't screw. This one, yep, yeah, but this one, this is very serious. It's very spongy, so this is going to be beyond your typical middle hole damage. See, look at that. I don't know if you guys can see this, but pressing along here, this is all spongy. So this is super spongy. All right, Chris Long says, I've had a few that pressure on the CPU on that corner was the fix, but that was drop damage, not long screw. All right, fine. Your fluke is off. It's practical enough for me. Okay, none of this is, remember, iPhone repair is Walmart repair. This is not a $10,000 space shuttle board. This is quick, 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 fast, fast, fast. So you don't really need to worry about, uber precise readings and things like that. You need to be close enough. The business of iPhone repair, it only makes sense if you can do the repair pretty quickly. When we do these videos, it's kind of this long, luxurious repair. I've already fixed 6 things today that are just sitting here recovering data. So I'm kind of having fun when it gets to be the time to do a video, just to kind of help people think, But this repair, as it is for me, would have been in and out the door in 20 minutes. So if you are needing to use oscilloscopes, then you probably should have said no fix before that ever comes along. That's just kind of for the fun of doing investigative stuff. It doesn't. No one needs to buy an oscilloscope for iPhone repair, period. It's just a fun thing if you want to learn more about a particular problem. All right, center hole. Okay, 1v8 center hole. Is the LCD working? Yes. Yes, it is. All right, so okay, so then let's continue on so that we can kind of get done with this, because this is starting to be too close to me needing to get a Diet Coke because this one's empty. So I better hurry up. All right, so let's look and see, before we just say, hey, fuck it, let's make a jumper and see if we can bring back camera, let's learn a little bit more. So let's see what else is going on. So let's see, let's go to ZXW tool. So now, here's the thing. We know that there is a big ass crunch mark. You know, somebody let one of the meteors that took out the dinosaurs has landed right here at BS 2503 screw hole. Pachow! You know, so we know just from experience the top layer of the board. So the top layer of the board has one trace through here, the 1v8 trace. Let's take a look over here. ZXW will show it to us. This is just the top layer. So just the top layer goes, yeah, see this? His name's 1v8 and he goes through that screw hole. But we don't really have any easy to find information on all of the other possible layers of the board and the millions of traces that go through here. So if you had to take a guess that at some point, somewhere in the board, let's pick this LDO enable has to go down in the board, and then magic, somewhere there's a highway, zzz, and it's got to poke its little head up under the CPU over here. So somewhere deep in the board is a highway that connects A to B. And if you had to take a guess, do you think it runs under this screw hole? Well, yeah, probably, as opposed to, you know, like going way down here, take a left at the LCD connector, turn right over there. You know, it probably goes somewhere real close to that screw hole. So let's look back and see our actual trace damage spot. So here we go. Let's flip that around so it's in the same orientation. So somewhere there's the LCD ball, or the CPU camera LDO enable line, somewhere around here, goes down into the board, travels. Is it coming into this spongy part? Probably, and then poking its head up here. It sounds really likely. In fact, let's drop a little drop of alcohol just so that you guys can kind of get an appreciation for how really serious this is. Let's see, I don't know if we'll be able to make that clearer or not, but when I poke, you can see movement. Sometimes when you put liquid on the board like that, you'll be able to see kind of movement of air bubbles. But look at that. Like, that is all, look at that. That is all spongy. It's kind of like a, you know, like your beautiful bow rider boat that you've got a great engine on and you just love the way the outside looks, but the floor is just spongy. It's just dry rotted all the way through. All right, so most of this is a ground plane, and we can see this one here is our actual, you know, fat trace 1v8. Is it, you know, not connecting to some guys that it's supposed to connect to? I don't know. One thing we could do is just kind of do a little continuity test over here. So let's lift this guy up and let's just kind of see, have we lost any continuity on 1v8 on some of these camera guys that are supposed to have it? Let's take a look over at ZXW and say, tell me a little bit about this 1v8 stuff. So if I look here, there's a trace in the board. This is 1v8. So I'm supposed to have my 1v8 going through this screw hole. It's supposed to connect this test point here is on 1v8 with this guy, and this guy. These are all filters that are bringing 1v8 to the camera itself. So probably that's okay, because none of that would really explain why we don't have our enable, unless we are missing a signal from the camera connector back to the CPU that says, hey bro, there's a camera here. So let's just do a quick test and see, do we have a 1v8 connection from, let's say, somewhere, somewhere else, like on this side of the board. I don't think we can get to any of that stuff under the shields. Yeah, let's just take like this resistor all the way, or are these guys all talking to each other? So let's do that real quick and find out. Let's find out. So let's just go, nope, not that. Let's see, what can we go to continuity mode, and can we see this? All right, and can we ask just a question here? Do we have a 1v8 at that test point talking to everybody else? I forget which ones it is. Yes. All right, so that seems to be intact, which makes sense, that we don't have some sort of a systematic loss of continuity of 1v8 kind of going through here. The only other test we could do is to just make sure that we actually have 1.8 volts being delivered out there. So let's go ahead and do that. We'll fire this phone on. So I'm connecting battery, and I'm going to connect prompt to boot, and I can see USB amp meter tells me that this thing is actually on. So let's go back to voltage and see, do I actually get 1.8 volts, which is kind of a brainstem thing. So let's see, do I get 1.8 volts on the test point there? I do. And do I get 1.8 volts here? I do. Great. So now we have kind of ruled out that I have some sort of a systematic 1.8 volt problem. So now the question is, why am I missing that enable voltage on the LDO? So there's only one thing that's sort of left to rule out, which is what makes the CPU say, turn on the camera LDO, enable, go, and shoot out that 1.8 enable voltage. What makes it do that? So let's just go back to the camera connector and stare at it long enough to see if there's anything that the CPU might require coming in that would say, thumbs up, we do have a camera connected, for example, or thumbs up, we do have, whatever information is required, incoming information is required in order for the CPU to go, okay, then that plus the fact that he just turned on the camera app means I should send out the enable voltage on the LDO. All right, so let's just check that. All right. I admire many of your mother. What? All right. I would think the process would be CPU says, hey, camera app is on, camera turn on, and send me data back. I doubt the CPU cares if the camera is there or not. I totally agree with that, and I think that especially because it is front and rear camera, I'd put my $100 bet on CPU is not listening for incoming information either. But since we know that the screen does, I think that it's worth ruling it out. So we're going to go on a hunt. So let's go back and look at that. We got to get back to the rear camera connector. So here's the rear camera connector, so that we can just kind of learn a little bit. And besides, the whole point of this is to just see what we can learn. All right, so all of this stuff is almost certainly data coming back to the CPU. So RCAM to the CPU. This is going to be the actual information, the pixels of the image itself. So that's not going to have anything to do with enabling stuff. All right, so then we've got this RCam AF. I don't know if that means autofocus or not, but we're gonna say that's probably likely. And then we've got this same old I2C data bus line. So this is kind of the general master and slave, where the CPU is the master and all these slaves that kind of have to quiet down and talk to each other. So there is some something going on here that could be enable, and this is a 1v8 line. So there could be some missing information in this I2C line, and that would be a little bit hard for us to test. But it could be that the CPU says, hey camera, are you there? That would be really, really likely for what's going on in this line. And that it needs the camera to say, yep, I'm ready to go. I'm not, for example, water damaged or broken or smashed or taken off the board or whatever. I'm ready to go. So it may be that the CPU needs to get a thumbs up there. We don't know. But in any event, we would expect to get a 1.8 delivered to this. We would expect to see some 1.8, even if it kind of flickered around, and not just a total 0 at all times. All right, then this PP1V2 RCam connector, we could go follow that out. That's going to be a power line that is maybe specific to just rear cam. And then we've got PP1V8 rear cam. That is probably a branch of all the other 1V8s, and we're pretty sure that we've got 1V8 in the general area. CPU to rear cam shutdown. So this is going to be kind of like a reset probably, or it's a way for the CPU to tell the camera to maybe dump its voltages, not really sure. CPU to the rear cam clock to understand some other data. Rear camera to the LED driver strobe enable. So if you were to say, give me a flash, it sounds like there's going to be a connection between the camera and the LED strobe drivers for the flash voltage to come through. And then here is our standard this is the line we've been following, the 2.85. So of these, which one is potentially not doing what it's supposed to do, we would have to say, all right, we could probe in a known good and see what the actual information is on all of these lines. So we could do that. Now the downside of that is that in order to actually probe some of these lines, you have to, it's hard to actually do it for some of them because you have to have the camera intact. So we would have to make little jumpers in order to do that test, to be able to see in the good versus in the bad what these voltages are at the camera connector and what they're actually not, and whether or not they're missing or not. So that makes that sort of a little bit involved, and I'm not sure I want to go to that level of detail. All right, so let's see. Amy is talking about 2.2K resistor won't pull up if something is wrong. So what is this resistor that we're talking about here? What resistor are we talking about? What resistor relevant to camera function? One of these guys? Let's see. You want to look at something going on over here? That looks like a cap to me and not a resistor. This guy back here? We got a little solder ball down there. That is also not a resistor. These guys in here seem pretty, kind of at a distance. You said by backlight. Oh, you mean those guys? Those guys are certainly not affected. You're talking about the regular I2C resistors that are all in a row. There's no like real rationale how those resistors would have any kind of problem, other than their line not arriving out here to the connector, which would be kind of the same problem of having to go through and figure out, are we not getting an answer from the camera on any one of these data lines, of which those I2C lines would be the number one pick on that for sure. All right. Pull up your referencing as a data line for feedback to the CPU. Are you talking about the ones that are in the standard line of all the I2C resistors that are near backlight driver? All right, this is, oh, you want me to write English? What? Afternoon. RO303. Oh, I know that guy, but that guy is just a, RO303 is one of your main I2C resistors. So if we didn't have RO303, we would have a dead phone. All right, I understand just helps if everyone's speaking the same language. All right, what? RO303 is definitely one of the regular I2C resistors. Let's see. To further analyze the structure of the camera, CPU is a shy little young lady, not listening. All right. Sensor data, temperature, anyone, ham radio, what? Touch, that doesn't have anything to do with cameras. I know it'll output power without both cameras attached. Oh, really? I didn't know that. Never tried. Whatever. I thought Jessa's little yellow voltage display was in secret mode. What? iPad rehab, RO303. Yes, RO303 is I'm almost sure from memory that RO303 is one of the standard main, gotta be there, I2C line resistors that you're gonna have a dead phone. RO303, isn't that one of my buddies? Yeah, RO303, yes, yep, this is I2C 0. So this line is the one that goes around and wakes up everybody, so that definitely has to be there, and it really wouldn't be relevant for camera. This is a camera specific defect. Everything is turning on, so if you didn't have that resistor, you would have a dead phone, where the CPU could not issue any instructions whatsoever. All right, let's go back. Okay. Make sure to try a new screen to that other guy. What? Coil? What? We're gonna get iPad Pro schematics. I've never had reason to need them. I would say use your brain. All right. Everyone, follow the link in the description for Repair Shopper. Do it now. Oh, way to go, Kevin. That's pretty good. And thanks for £5, Kevin, and the ad. All right. Okay, so let's go ahead and that's really funny. Click the link, the Jessa link for Repair Shopper. Do it now. Yes, I've got my Repair Shopper t-shirt on today. All right, let's get this kind of finished up then. Let's maybe do, let's just kind of do one more experiment, and then we'll move on with a jumper and see if we can get it done. Let's go back to the rear camera connector. So let's go to, where is the search? Let's go back to U2301. U2301 is on the same page as the camera connector. Where is it, mofo? Where are you? Right here. Okay, so our question is, we know that we are missing our enable voltage. It's supposed to be 1.8 and it's not, it's 0. So we know that this line goes straight back to the CPU. So the CPU either puts 1.8 there or it doesn't. So the CPU is putting this here or not. So it's not doing that. So why not? It's not doing that. One reason is because it doesn't have a path. That because of the long screw damage in this phone, this line is actually severed between here and the CPU itself. we could test for that. It would be really too difficult, so I'm not that into it. But we could test for it if we wanted to by taking an iPhone 6 bare board and drilling down and actually mapping from under the CPU to figure out where exactly does that trace go, so that we could map it and kind of figure that out. So that we could do that. I'm not really sure I'm into that today. What's the alternative? Why is that line not there? It could not be there because the CPU is not getting some kind of input from the camera connector, also because of long screw damage. So we could, just for fun, just kind of ask the question of, well, what kind of information do we need to actually have on, like, let's say these lines here that are maybe not making its way back to the CPU. So we could kind of test that between the known goods or the known bad. So of these two, can you just remove U2301 and check the enable line? Well, there's no need to do that because we can just check the enable line without removing U2301. So here is U2301 right there, and we have no reason to suspect that U2301 itself would have had any damage, and so we can just put a probe on there and see that that is in fact not 1.8. All right, so let's see. I think of those two options. Let's see if I happen to have an iPhone 6 bare board. That one might actually be the more fun one. Let's see. Let me go on a quick hunt for that. All right, I'm gonna hunt down this. Let's see. Is this iPhone 6? That's a 6S. I need an iPhone 6. iPhone 6 bare board. All right, let me look one more spot. iPhone 6. This looks like it might be it. Let's see. Yikes. Are you an iPhone 6? You kind of look like you are. All right, let's find out. Let's find out. Let's find out. All right. All right. Is this an iPhone 6 bare board? Okay, so what we're interested in is the enable, this guy. And let's get multimeter in continuity mode. All right, so let's make it so you guys can see that. So you go to one of these guys. That one. All right, so now what happens if we try to figure out kind of a path? Where exactly does that go? So let's do it. Let's dig. Let's see if we can kind of figure out where its actual journey is through the board. We have to kind of get rid of some of this. Do some research. All right, so that's it, still there. So it's going down to Chinatown. All right. Where does it go after that? Where does it go out? I need to order some bear boards. They look so pretty. They are pretty until you just rape the shit out of them, like I'm doing right now. All right. Then where do you go, mofo? Tell me. Where do you go after that? So we're just kind of filleting away and trying to see where these guys go. Well, look at you. You get big. Get big for your britches. All right, let's make sure that that's still our guy. All right, let's see. Is that still our guy? One probe there. And one probe here. It's hard to see them both at the same time. Ooh, maybe we can. Are you still our guy? You should be. You should be. Yeah, you're still our guy. All right. So let's see. Looking at that bear board makes me want to build one from scratch. Jessa, is there a method to iPad mini data recovery without the PMIC? If you're talking about the 3v3 out short, yes, there is a method to data recovery, which any practical board repair school graduate will be happy to tell you. All right. So I hope you didn't take the PMIC off for that. I mean, you can stick iPad mini PMIC is doable. I used to do it just for repair. All right, let's get rid of this ground plane and see if we can find out where this dude goes after this. All right, where's his next destination? All right, so here's our guy. Where do you go next, buddy? It's like you get skinny again. You get skinny, and where do you go? All right. That logo size really hurts. What? Hurts what? All right, I think that's our dude right there. Just kind of tickle him. Okay. Ooh, now he's on the move. He's going somewhere. Where are you going, buddy? Going over there? We have to scrape off a few layers of this shit so that we can follow him. He's on the move. So we're just tracing, just kind of figuring out really where this guy goes and whether or not he goes really under that screw bracket or not. If he doesn't, and he looks like he's kind of snaking away at a distance from our screw bracket, at least right now. So that's kind of interesting. So let's just kind of reconfirm that what we're measuring is actually our guy, the LDO enable pin. Poor board. Holy shit. RIP board. All right. So let's see. Are you still our guy? Yep. So now, let's keep doing this a little bit and see and see where it goes, because now we're kind of having less evidence that the reason we're missing our LDO is enable pin is because of the trace damage, because this trace does not seem to be tracking along that screw hole, at least not right now. Maybe it will kind of come back, but not right now. It's not. It's heading over here, heading out to the edge of the board. The carefree highway. Where are you going now, bro? So it danced its way out here to this kind of on top of the home button connector area. Now where are you going, buddy? Which way? It's like playing hide and go seek with a little kid. Just kind of like following a toddler around the gym. Where are you gonna go now? It is like fingernails on a chalkboard when you gotta like get a couple layers off at once. You sure you're not a woman driver? You don't seem like you're going anywhere near towards the CPU. But what do I know? Aha. Microvia. He's gonna go down. And that is his trace. That is his line on that layer. So from here, he's gonna go down. What's with the makeup today? I am not wearing any makeup. I don't really get this. This camera like is weird with the lights or whatever. But this is Saturday morning. Something's up with that camera. I don't know. All right, so let's see. Is this what she does for fun? Yeah, totally. You don't think it's fun to follow a trace? What's wrong with you? What kind of stuff do you do for fun? I think it's very zen-like and relaxing after the horror of having to finally go get a goddamn new truck last night. I'm like the least excited person ever at the Ram dealership buying a truck, where I'm like, okay, fine, blah blah, and then I get this truck, and then I have to try to go get the camper, and the guy calls me. He's like, you know, that truck, you know what? We just put a hitch on it, but it does not have a portable brake controller. Great. Well, how did you guys not bring this up, you know, anytime this entire week before right this second? So then I had to try to get one. It's late. I really have no patience for it at all. And then I made the fatal error at the campground of trying, when you're trying to do something, is attract the attention of the helpful old men. You never want to do that. Attracting the attention of the helpful old men is a great way to get stuck there forever. So I then had to extract myself from the helpful suggestions of the helpful old men. David Rowe donated $5 out of compassion for me having to talk to the helpful old men. Thanks, David. At the campground, which was painful, but eventually it got the camper hooked up, drove it past the scene of the crime, and made it back to the RV repair place. And then it took a half hour to figure out how to get it off the hitch in the dark, because it wasn't the same as the old hitch. And finally got home. So yes, this, oh no, I scraped too hard. All right, now we have to guess that this is my same line, but I'm not 100% sure since I scraped it too much. All right, let's do a little test and see. Is this my same line? What is the name of what she did? Rub-off job, hand job. Whoa, you guys are a little cray-cray. All right, so let's zoom back out and say, do you still go here? You do. All right, so you're still my buddy. Good to know. All right. So we've pretty much got our answer here on the path of this line. It goes under this connector. And here he comes. Here he comes. So it's unlikely now, from what we've learned, it's really unlikely that we have a problem in our LDO enable line that is from the long screw damage. So that is now less likely. But we could, if we wanted to, we could at least kind of, let's see where this goes to see if there's any place that it branches out where we could kind of dig down to it for fun and measure continuity if we wanted to. Seems to be coming in straight. Yep, nice long straight line. Looks like it might be going somewhere there. Wait, Pepe, what? Wobble cam, can't help you with that. Laser ablate the solder resist. Use a new blade, dear Jessa. I probably should do that. The board whisperer. Well, I don't know about the board whisperer. All right. Where's it gonna go now? It's gonna go over here. Let's see. Why is it gonna go over here? So are you guys telling me that like pads or something, which I really have never bothered to look into, that it'll tell me all these traces? Tells me all of these already, so I don't have to. So you're going to take away my Zen luxury of following traces on bare boards? Is that what you're telling me? Who's a pads user that can tell us if that's really true. All right, come on, buddy. Where are you gonna go? Man, that's wild, isn't it? Pretty sure it's this line right here. Just kind of think it would be fun whenever it's going to come up here at some point where we could actually get to it. That would be kind of fun by this other screw hole. Ah, if I don't lose it. Oh man. Sandblast that shit off. And the lottery rubbered number is... Chris Long says, I know pads had something that did layer traces, but I don't know if they traced all the layers. Maybe a Dremel would work better. I think this is working fine. Alright, so we are, what layer are we in anyway? That's the first layer. Here, I'll try to hold this microscope with my finger so it's less wobbly for you guys. We're getting close to the mothership here. So I'm just kind of scraping around here to say, what would it take at the screw hole? Like there is kind of a space in the board here at this screw hole. Like what would happen if we took up this screw hole? Could we actually find this trace without digging up too much board? I think the answer is no. There's like too many other things we'd have to fix in order to get down to the layer of the board that this guy's in, which is a drag. I want to make sure I'm following the right guy again. So let's back it up and take a continuity measurement. I'd like to see this video sequence in reverse. She seals that shit perfectly. Yeah, that would be pretty fun. Let's see. Yep. It is that one. Wake it up, multimeter. All right. Now I kind of want to see, where does it go from here? Where does it go from here? That might be harder to find. Where did it go from here? Deep, deep, deep. Can't tell if it's attached to that or not. I kind of don't think it is. And let's go back to this. All right, so I think that there's no way that we'll be able to actually like dig into our board and test whether or not we have a loss of continuity from under the CPU to our LDO enabled trace. We can find it, we can know where it is, but in order to get to it in a real board, we would have to do it's way too much. It's way down to too many layers down. Too many layers down to be able to find a convenient place to just kind of dig it up and test for continuity. Or similarly, to dig it up and run a jumper. I was hoping that it might be in the second or third layer around this screw hole, in which case we could say, hey, let's tap into it and bring a jumper back. But the reality is that it looks like it is down in the like fourth or fifth layer, and we would have to do too much cutting away in order to get that back. All right, but what does that also mean? It also means that we're gonna we don't really have a rationale for why that line is missing. So from the CPU, because of long screw damage there, because from the CPU it looks like the root of that line is not across the path of the majority of the board damage from the long screw damage. It looks like it kind of goes down over to the other screw hole, and then it goes underneath the connector, and then it kind of crosses over and it comes back. So that kind of lessens our likelihood that the original fault is a simple lack of continuity between the actual camera LDO microvia and the CPU. So Chris Long suggests why not test for open line, which we can do to see. Let's just kind of do a diode mode test then of that little line. So let's make it so that you guys can see that. There's no need to actually take the LDO off, in my opinion. Let's take this, move it. Alrighty. Can't see it as good as you could. What did I do? What did I do to it? There we go. All right, so let's do red probe on ground. And this is our actual test one. All right, so diode mode is 0.45-ish. And let's go to our good one, and do a measurement. Red probe on ground, and this is on that line as best I can, and it's giving me OL. All right, so OL is the diode mode reading on my good one. And less than that is my reading on here. At least it was. Is it still? Nope, no, that's reading OL. Let's try to really get that reading. It's hard to get everything touching. All right, you are touching ground. You touch that spot. I know it's hard to do. All right, OL. Ground, touch that spot. Oh well, all right, so there's not a mismatch between our good and bad on that. All right, so then we kind of are left with, why is it that the CPU is not sending out that signal? And it's going to be, well, then presumably it's because somebody else let's go to screen. Somebody else here is not replying back with whatever it should be. So that's really kind of, it's unlikely to be power line. So it's likely to be really one of these two guys would be the top guess, or it could be this, like AP to RCAM shutdown. So if this is supposed to be a 0, for example, and it's grounded because within the trace damage area, for example, whoa, that's not microscope. Within the trace damage area, what if the RCAM reset got accidentally mushed into ground? Then that could be a reason why the CPU is not putting out that voltage anymore. So I think it's probably worth it, just because we've already done this for a while, to let's just kind of probe. Let's go ahead and probe that shutdown. Let's see. So where's a good place to measure this? The RCAM shutdown. Let's go back to ZXW and say, which one of you guys is RCAM shutdown? There we go. Shutdown. RCAM shutdown. So this is supposed to be on this filter, and it goes out and looking for a spot that we could measure it without getting into too much trouble with a connector, because the connector needs to be there. All right, so AP to RCAM shutdown. Let's go ahead and see if we can get a reading on that on our known good and on our test. So let's go ahead and get the known good first, which is this one. So again, I need to activate the camera app. So that means I'm putting on a screen with everything connected. Screen with everything connected. Press on that CPU. We'll see. That would be in like really kind of, that would be too random, but we can do that. All right, so let's let this wake itself up. All right, drop damage causing a cracked ball. I don't know, it's just too, there's that middle hole is just too close with clear third layer damage. I don't think that's unlikely, but we'll see. Where can you get one of those board schematics? Anywhere on the internet. Just ask, hey bro, internet, hook me up. I was using epoxy until I found UV mask. Yeah, me too. I just want to say I love your channel and really have big respect for the work you do. Waves from Norway. Fantastic. Thanks, Norway. All right. Let's wake up the camera app here. Okay, okay, okay. Camera. All right, camera's still working here. Front and rear. So we're going to leave it on rear. So much work on this repair. Well, this is not work. This is play. Not like, just to be clear, this is I would never do this just for work. This is exploring and having fun. This is hobby. And I think that's important sort of in business. The business of repair for this one, I quoted that because I already knew that the likelihood that this was going to be just that the camera LDO had come off the board. That's why I quoted this repair. My expectation was to take a look and replace that camera LDO chip and be done with it. If it had some other problem, then like if I quickly measure and I don't get 1v8 on the camera LDO input, then I would make a jumper there and it would go out the door too. I wouldn't jump across the camera LDO, but I would jump the enable. That's what I would do for this repair. So this is like a 10 or 15 minute repair. We're just kind of playing around with it today as an example of how you can learn a lot if you feel like kind of taking an interest in one specific problem, and then you kind of can apply that to other problems and just sort of see different techniques and ways that you can learn. All right, Pepe thinks this phone is from Nebraska. All right, so much work on this repair. If it was me, the customer would have to pay more than what the phone cost. Then your customer would tell you to suck his dick. Okay, so let's see. I don't really remember where that resistor was. Let's go back and look. Where are you, resistor? Let's see. But I think I am about getting to the end of my patience with it. It is fun, but you gotta get busy after a while. And I'm doing this because I came in today. It's the weekend. It was stressful yesterday, and so it's kind of relaxing. This is my hobby. It's fun. And I already did six data recovery jobs. I just kind of have to sit here and plug through, so it's fine. All right, so this is the dude. This is the guy next to it that we can easily measure. Then there's two guys there, and we got to get to that side of the one under him, which is going to be a little bit tough. All right, so let's see. We want to measure a voltage reading. So we're in voltage mode on the multimeter. And let's see if we can actually reach that spot or not. First, let's check to make sure that we still have camera app open, and we do. So camera is working right now. And we got to get to E. I think we can do it. It's going to be tough, but I think we can get to it. That spot right in there. There to ground. What do I get? All right, 1.8. All right, so 1.8 is what I measure on the camera shutdown line. Now, if I was smart, I'd solder a little wire there so that I could see what happens to that line as I actually try to turn the camera off. I'm going to measure it. I'm just going to flip over to front camera. So now front camera is open. And I'm going to go back to that rear camera shutdown line and see what happens to rear camera shutdown now that front camera is enabled. All right, so rear camera shutdown. It's hard to get a probe on it, but I think that is it. And it's still 1.8. All right, now I'm going to see what happens when I click out of the camera app. So I'm going out of camera app. All right, so now camera, it's back at the home screen, so cameras are off. And what is on my R cam shutdown now? Can I get a foot on it? All right, it's 0. All right, so now we've learned something. So what did we learn? We learned that when the camera app is open, the line called R camera shutdown, so let's review that. AP to R camera shutdown is high, so it's held up to 1.8. So 1.8 is kind of like preventing it from shutting down maybe. And then when you click away, that goes down to 0. All right, so let's Let's see. She needs to build a robot with the face of his friend, Louis Rossmann. That doesn't make any sense. Jessa, can you build a robot? Probably not. All right. Where the hell is Louis? California. All right. So let's then see, is there a difference between this finding, which is a known good, and our phone itself? So let's see. Let's see what happens to that shutdown line. First thing I want to do is check to see, is that shutdown line shorted to ground on our known good. So it's not shorted obviously on our known good, but let's take a diode mode reading. Diode mode reading on that same R camera shutdown line. What is it? Oh, and the camera died. That means it's time to wrap this repair up. Camera died. Camera died. Time to wrap this thing up. Time to go home. Need to go to the gym today anyway. All right, so now that looks like it says oh well. It's hard to get the probe in there. Oh well, okay. And let's check on our one board we're trying to fix. Diode mode on that shutdown line. Also OL. All right, let's stick a screen on that. And plug in our cameras. Let this board wake up. All right, booting this up, and I'm gonna go tell the camera to charge. All right. I had to leave the state. I didn't want to get stabbed with tweezers for wishing marriage upon him. Who, Louis? Let's see. Let's plug this in and let this charge. All right. Now my camera is charging. Is the shutdown line static or pulsed? We didn't bother to find out. All right. Why does everyone keep talking about Louis on other channels? It's silly. I talk about Louis because he's the person that I talk to quite a bit in general. So I talk about my kids, or I'll talk about people that work here. And Louis is a friend, so it would be natural to talk about him because he is a big part of funny shit that's going on in life in general. All right, camera app is open with no camera function as expected, so let's check on that line here in our dead board. So we're going to go back to voltage, and we are going to see what we can get on this camera shutdown line. So we got to kick off our home button, just make sure we're still in that camera app. We are, with a dead camera. And that resistor, which was just there, is now officially knocked off. But let's still see what that voltage is there. And it is a 0. So it should be a 1.8 there. But it is not. It is a 0. And that resistor should be a resistor going to ground. So that wouldn't cause that to be there. All right, so that is, shutdown line is low, inappropriately low. let's click over to front camera and see if anything's different. So here we are at front camera. And at front camera, we also have 0. So that is not correct. Let's go look at the screen then. So now we've learned that the CPU to the rear camera shutdown, which is supposed to be 1.8 when the camera is active, is actually a 0. So let's kind of see if this goes anywhere else. So let's follow that and try to think, why is the CPU trying to shut this camera down? All right, so let's follow it. And it looks like it goes over here through a filter. And then here's the resistor that we just knocked off. And it should go to the CPU, it should. Let's just kick off the end there. Yeah, there it is. So here at the CPU itself, shutdown is also reset fcam. Good to know. Let's just clear out this text. All right, so the CPU itself looks like it has this I2C information for the front camera and the rear camera, which is probably, hey bro, are you ready? Everything good? Give me a thumbs up. And then this this goes out to this is a clock line that goes out to the rear camera, which may be used to time the data line that come back. And then we have reset front cam, and then we have this shutdown line. All right, what else is going on over here? This is the camera LDO, and then this one here also, which is AP to Stockholm, this DWLD REQ. It seems to be kind of in the same area. All right, and then all of this is just sort of data. And then we've got this sort of path to ground. That guy is at a distance from this. It's over there by the LED driver. All right, so the next thing would be to just wonder whether or not there is something that if this line is broken for either front camera or rear camera, that if it's just saying, hey, querying camera, are you there? Camera, are you there? And if it doesn't get a yes, then it might actually just hold this shutdown line low instead of high to kind of basically hit the off button on the rear camera, and at the same time the CPU would fail to produce this camera enable signal, since both of these are not what we're expecting and they're coming from the CPU. So then my next question would be, what is it supposed to be getting on this RCam or FCam data lines? Are those damaged between the CPU and the rear camera? So we can't really easily, that sucks. We can't really easily go after that, but that would be what I would be thinking next. So let's kind of get this off. Also, in that case, if you did just sort of jump the 1v8 to this enable, you might not actually bring camera back if this line here is, if this reset is low, because you also need the reset to be 1v8 as well, and it's currently not. So you could see what happens if you just put 1.8 here and not, you know, it sort of one or the other of these, and just kind of see what happens. So next you could just kind of query which one of these are the I2C lines and do the same kind of thing, where really the logical guess as to what's going on here is that there is a break somewhere in, you know, a trace damage problem, probably in here somewhere, where I can still see a real significant sponginess. Under here, I can still see a significant sponginess there, that something is broken deeper in a layer, you know, down under some of these layers, that has to do with communication between the CPU and the rear camera, or the CPU and the front camera, maybe. But that line, whatever it is that's broken, is that's gonna be really tough to find. I don't think I'd be into that. All right, so for now, let's just see what happens if we just kind of put some jumpers just for fun. Let's see if we can get camera function back. If we just, let's start with just the camera LDO to 1v8. And we'll just take this sort of random 1v8, since it's time to kind of wrap this up and we want to just kind of do something rather than just mess around all day. All right, so let's just give this 1v8 with a little bit of piece of wire, and we'll see what we can learn. All right, here we go. All right. Who's SimIO? I don't know. Let's see. Where is this? I bet you all of Jess's dreams are about iPhones. Probably not. Let's see. Let's make a piece of wire here. All right, let's just get this 1v8 cleared out and tinned up. And let's get this one cleared out and tinned up. One of the data recoveries that I did today is from a DIY customer who has previously sent us 2 other phones for data recovery. And I really want her to learn how to back up her phones. That is just sad. All right. Need to make sure that's not touching ground. All right. Amy Marie says, fuck. I think if Lewis were to fall in love properly one day, a lot of his views would change. I guarantee it. You are absolutely right. You are absolutely right. A lot of what he claims to hold as certain views, a lot of what he says makes sense, but a lot of his sort of depressing and darker views are based on some experiences. All right, just make sure that aren't you supposed to be ground already? No, I thought one of you guys was supposed to be ground. All right, let's see what happens if we just make a wire to 1v8 over there. All right. Long screw, right? When you guys start talking about some other phone, then I can't follow chat anymore, because I don't know if you're asking questions about the repair that we are working on, or if you guys are on the side talking about some other phone. So if you're asking an iPhone related question that's not about, or a comment about this phone, or a phone that is similar to this phone that you've fixed or thought about before, those are all make sense to discuss. It makes sense to kind of, add to the discussion any relevant experience you might have on a phone similar to what we're trying to fix. But if you start talking about someone in chats asks an unrelated iPhone question and then other people start giving him answers, let's not do that. If you have an iPhone question that is not relevant to camera or LDO or something that you think would contribute to our ability to think about this problem, then go post on a forum. There's a lot of great forums that you can get help with. I'm not into please bro, questions on chat or anywhere else. So go post on a forum. I would recommend the Introduction to Microsoldering group forum. Lewis has a paid for iPhone repair or iPhone forum. There's a lot of great forums out there for iPhone please bro help. But Jess's live stream is not one of them. Alrighty. So let's take this over here to the land of 1v8. All right. And now we are going to see if that makes a difference. So we didn't do anything to our reset line. We left that alone. And right now we're just seeing what happens if we put 1v8 on just the LDO enable line. We're going to take a shot at that. And I think that I am running out of the time that I want to spend on this repair because it's about time for me to go home. So let's hook up that camera again and then we'll just kind of see what we can learn. Jess, I've noticed you're friends with everyone except Jason from Microsoldering, the M1 Jumper founder. What? Jason from Microsoldering is the M1 Jumper founder. The M1 Jumper founder? What? For the 6+ disease, though he's pretty good in sharing good infos for the community. It sounds like you're confused. The M1 Jumper is something that I think the entire community kind of independently arrived on. I would credit Chris Long as the guy who first put the time into doing an experiment to really formally address what does the M1 or the HIFA B-Sync line actually do, and to kind of linking that to the gray lines. But for microsoldering, I think you're talking about Michael Huey, who I've just never met in person. Let me see if I can get this camera to work again. It feels awkward to not have camera. It feels weird. Let's see if this will give me a few seconds just to kind of get to the end of this. All right, that might work for a second. Not sure. Let's see. Yeah, kind of. Now it's way over there. Close enough. So I have never met Michael Huey from microsoldering.com, and I've never met Jason Vilmer from SDS Telecom. So I just don't know those guys, and they're not really a part of communities that I talk to a lot of people on. So there's a lot of people that I have met in person. Chris Long I've met in person fairly recently. I've met Larry Johnson in person, and other people that maybe I haven't met in person, but I've talked with them in communities and forums for years, like so that I feel like I know them in person even if I haven't. So that if I've met a lot of folks at conferences and et cetera. Lewis I talk to every day. So I don't, Jason Gann used to work here, and now he's microsolderingsupply.com. So some people I just happen to know because I've met them in person, hung out with them, met them at a conference, or we've developed a friendship through other online relationships over years. And some folks just aren't really a part of the communities that I hang out in. So that's all. If you overheat the IC or put it on backwards, you can cause a VCC main short. I still don't know if that's the same phone or not, so I don't know what you're talking about. 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 What would you do if you have an iPhone come in with an issue, small issue like cameras, and it ends up dead from testing? How do you handle that? That's a good question. So that's why I wouldn't take risks like putting heat on boards for small issues like cameras and things like that. So that really doesn't happen. That I can't think of a scenario how you would take a phone that came in with a small issue like cameras and it ends up dead. So if it does, you got to figure out what you did to it and undo it or not do that in the future. And you would really have to just accept that as part of your risk of doing business. So if somebody brings you a phone that has no touch, that's the same as a dead phone because you can't use it. But if somebody brings you a phone that doesn't have cameras, then you have to be appropriately cautious. Like right now, on this phone, because it doesn't have cameras, I'm not gonna say, yeah, let's do the CPU drill out thing and see if we can get this enable line, which we've now learned is unlikely to be a fault of a lack between the CPU. But while we have this phone on here with no cameras, despite the jumper, we'll go ahead and press on the CPU for Chris Long. Here we go. Let's press on that. Come on. Do I have to do anything else? I don't see any progress. Come on, turn around, front camera, rear camera, no camera, back and forth. Pressing on the CPU has no effect on this phone. All right, which makes sense. How do you know they aren't short? That sounds like you're still talking about somebody else's phone. Let's knock that shit off. All right. I have them sign a waiver. I'll replace the phone if it's from my negligence, but no other reason. Yes. Step 1 for Lewis and Love. Move out of New York City. That's right. All right, I really can't follow when you guys start talking about other phones. Jessa said we can't help you with another repair. That's exactly right, because when I look up to read comments and I see all of these things about check enable 1v8, I don't know whether or not you are suggesting that for this phone, and we can talk about whether or not that's a good idea or why, or if you're discussing somebody else's side phone. So you're gonna have to knock that shit off. If you have a question about an iPhone, post it on a forum. If you have a question about this phone, post it here. All right. Do you think I can fix camera front and back? That is the only problem in my iPhone 6. Yes, I do. All right. Not microsoldering.not. Jason from Microsoldering. You mean Jason Gann from microsolderingsupply.com? Microsoldering Supply is different than microsoldering.com. And there is some of these kind of annoyances in the industry where some folks with similar domains kind of try to, they fail to make it clear when they attract a customer that's clearly for the other guy. That's a little bit annoying. But no, Jason Gann from microsolderingsupply.com was just on here. He just did a video with him. He came up for the course and to hang out a couple weeks ago. All right, that's a big can of worms I don't care about. I share info to help, so I don't really care to claim who figured it out. The community knew missing M1 equals no touch. Yes, exactly. And then Chris Long is the one that took the time to do the experiment to just show that demonstrates that conclusively, rather than just kind of saying, yeah, we all knew for a long time that's the only pad that's missing, so stick a jumper there. All right. Jessa needs a banner that says, don't ask questions about other phones. Yeah, exactly. Don't ask questions about other phones. All right, so the last thing that we're really going to do for this phone is let's just see what happens if we, so we don't have, despite our jumping the 1v8 on our LDO enable, we don't, let's see if we still don't have the output of that, which we didn't actually test. So let's do that real quick. We are going to measure our output, and then let's go back to voltage. Let's make it so that you guys can kind of see that that is no longer in the same spot. All right, so let's see. All right, and we are going to measure voltages. Oh, I can't even see that now. All right, I need to be able to see my voltages, so I'll just have to tell you what they are because I cannot see that super teeny little camera. All right, let's do this. All right, we're turning the phone on, and we are going to go navigate to the camera app. And we're going to get finished up here one way or another. All right, camera app. All right, camera app is open. And let's start measuring some voltages. So with the trust-based multimeter, like that, you know, like the word trust-based multimeter, you know, that's something I said, but Lewis says it now, you know, like who cares? Like none of that's really that big of a deal. 1.8. Now let's look at our LDO output. Our 1.8. And then what do we have here? We have on the LDO output, it is flickering around at 0.11. 0.11. So that means that despite being enabled, the little LDO is not able to do his job. So we've got VCC main, 3.9 is present here. Yep. Forget which side is the side. So we've got nothing here. We've got 1.8 on enable and no output. All right, so that means the next step here is to replace that LDO chip. All right, so the LDO is actually just not working. Alrighty, and I think that it's, yeah, this has been long enough for me. So I'm gonna be kind of done with this because now here's what needs to happen. We need to replace the LDO chip on this, but I think that what the point of this video was, at least for me, is to just kind of see different tools and strategies that you can use to investigate kind of an open-ended problem. So we looked at, you know, something that's a pretty simple problem. Why are cameras not working? And then we looked from the connector to figure out how are they supposed to get power? How are they supposed to get data? And we found logically our way back to one thing that controlled power to both the front cam and rear cam. What is that guy supposed to do? He's supposed to put out power. Does he have his input power? Yes. How does he know to be told to turn on? The CPU has to tell him. Why is the CPU not doing that? And to just sort of show how you follow this really logical progression where you just kind of keep asking questions and going back and back and back. So so his enable signal, the CPU is not putting that signal there. Why not? Is there a short to ground? No. Is there a loss of highway? I don't know. There is long screw damage. How do you figure that out? Let's try to figure out where does that highway go? And just sort of show how you can be really logical and just kind of ask these questions without really knowing a whole lot about electrical engineering. It's just about using your brain and being a bit of a scientist and kind of thinking it's fun to follow these lines of investigation and figure stuff out. And why would anybody spend time on this? Who cares? Nobody's ever going to pay you that much to fix their camera problem. And the answer is because you can discover signature problems where you might, for example, spend a couple hours looking at this camera chip, and then the next time you get a phone with a camera problem, then you might very quickly just know where everything is and just know very quickly, let me just test here for this LDO output, yes or no, and suspect the chip or whatever and solve things very quickly. So that's sort of the point about that. All right. First agree, I actually posted my findings on Facebook 2 days before him, and our first jumper for prevention was done in November. He posted a video in December of 2016. Who cares? Who are you talking about? Michael Huey? Chris Long? Is this about Michael Huey? I'm guessing it is. Would have been solved either way. Happy it's been put out there. YouTube chat, Google help community, blah blah. No one is getting an award. That's right, exactly. Bearboard. Did the LSD break anything? Not in the first layer, but we don't really know. Go find a forum. Yes, you just need jumper or changing. Not, oh God, no, come on, tell me why you can't jump this LDO. God bless it. Yes, probably the shutdown line. Did the board kill the new good cam? What new good cam? I don't know what you're talking about. How did this LDO have died? Well, that's a good question. And we don't know the answer to that, but we do know that it is in an area that had significant screwdriver damage. So it could have been killed by just some kind of mechanical disruption or something like that. The LDO is dead because we just gave it a 1v8 and it did not put out any output. Everyone gets a participation award for hurt feelings. Yes, thank you. All right, so the next step with this phone is to go ahead and just replace that LDO chip. But still, that doesn't explain why it doesn't have enable, and also why its shutdown line is low instead of high. So it's kind of still a bit open-ended, and we just would continue on doing the exact same thing that we are now, to just sort of see whether or not we can come up with the, whether or not the I2C lines are failing to tell the CPU, hey, I'm here, in which case it then responds by not sending out camera voltage enables signal and also holding the reset low, things like that. So it's still just an open-ended problem that we can continue to troubleshoot, and there's lots of things that we can try. That'll be fun. The next thing would be to replace that LDO chip and see whether or not we get our output voltage out of that, because there doesn't really seem to be anything else that would regulate that. All right. You can go back to the beginning to read the problem. The cam you use, is it still working in the other phone? Yes, it is. We verified all of that at the beginning, because you don't have a board problem until you know that you don't have a parts problem. So we definitely ruled that out. And I am out of time. It's time for me to go home and go do something fun and check in on all of these data recoveries. And I'll either fix this and update you guys, or we'll come back to it another time. So that's it for me today. See you guys later.